Hello everyone, once again welcome to my channel. I am Ajit Lode, Assistant Professor, Yashwantrao Chavan College of Science, Karad. I already started lecture series on course Engineering Geology, which is useful for BSc 3rd Geology student as well as civil engineers. This is lecture number 6. Previous lectures I was discussed Introduction to Engineering Geology, engineering properties of rock, soil, building stones, various soil groups of India, then types of bridges. Now today I am going to discuss geological consideration during bridge construction. So let's start the lecture. Geological consideration of bridge sites. Investigation for bridge construction. Aim of investigation. Why investigation is important? To select the most suitable location, type of structures satisfying optimum cost, road alignment, demand of traffic, the stream, safety and aesthetics. Investigation of bridges. Selecting the following parameters should be carried out under bridge investigation: service life, location of the bridge, deck level, bridge type, span, piers, abutments. Bad decisions regarding location and the structure can lead to several problems. High investment is needed to construct a bridge, so it's important to make the right decision first. The preliminary geological investigations or desk study. You have to collect topographical maps, contour survey available from the survey department, remote sensing images if available, aerial photographs, stability of stream by viewing photographs of multiple years. Then preliminary data can be collected. In that, first one is name of the river or road, probable bridge location, any close to by bridge on the same river, location of the nearest available benchmark, present and anticipated future volume and nature of traffic, hydraulic data pertaining to river. Then fifth one is soil profile, then navigational requirements of the stream if any, material availability to location, source location and transportation is important, utility and service supply during construction. These are the 8 preliminary data you have to collect. Then design service life. The purpose behind construction of bridge. In that, first one is permanent structure or permanent bridge, service life more than 40 years to carry the specific load. Or second one is temporary structure, when an anticipated future development after some time will increase the decreased capacity, low cost temporary bridge until the development occurs. Permanent abutment and a light deck may be a wise alternative. There are 2 types of structures, permanent structure and temporary structure. Permanent structure, the service life may be more than 40 years, and temporary structure, it is only for the development purpose. So here permanent abutment and light deck may be a wise alternative. Then location of bridge, another important aspect. Steady stream flow, no serious wheels or cross currents, then narrow channel with firm banks, suitable high banks above high flood level, rock bed or any other hard inerodable strata close to river bed level, economical approaches, then appropriate horizontal alignment of the road to be connected. This is once again important factor. Any calamities occurred on the bridge, we have to divert the road through that alignment. No sharp curves in approach. Appropriate vertical alignment also occur. Absence of expensive river training work. Absence of extensive underwater construction. Traditional crossing points. Care should be taken to investigate a number of probable alternative sites and then decide on the site which is likely to serve the need of the bridge at the least cost. However, it is not always possible to have a wide choice of sites for bridges. First one is deck level. Determination of the deck level should be done based on hydraulic study. When a bridge structure and its associated embankments encroach upon the flow of the river in flood, there is a risk to the structure, the embankments and the surrounding land. It is not economical, however, to build a bridge to clear a wide floodplain because bridge works cost more than earth embankments. Often bridges are designed to accommodate annual high flows without excessively restricting the flow of the river. River survey. Obtain the following data. You have to obtain the following data: ordinary flood level OFL, lowest water level LWL, highest flood level HFL, highest known flood is termed the high flood, design flood level, the annual high flow is termed the design flood. River flow, maximum discharge to be estimated by empirical formulae, rational method, area velocity method, record of flood discharge. It is preferred to estimate the flood discharge by at least two of the above method. Once again, I would like to repeat the methods: empirical formula, rational method, area velocity method, record of flood discharge. These are out of that you have to prefer at least two methods for estimating the flood discharge. Restricting the flow of design flood can cause either excessive backwater resulting in flooding upstreams or a scour that may damage the structure. The bridge part should also be designed to withstand the high flood. On important roads, the bridge may be designed for a design flood occurring no more than once every 10 years and a high flood once every 100 years. This is important one. Once you construct the bridge for important roads, you have keep in mind these things, that is flood no more than once every 10 years and high flood once every 100 years. A minor road may be served by bridges or low water crossing, allowing water to flow over for a few days every year. The bridge designer is required to select design flood level, a design discharge, that is flow volume, and a design velocity on which to base calculation of waterway geometry, foundations, depth, score protection, and vertical clearance. The design flood is the maximum flow that can pass through the bridge without causing unacceptable disruption of traffic, endangering the pier and abutment foundations with scour, damaging approach embankments, causing flood damage on the upstream side of embankments. The high flood is the early occurring flow that it is uneconomical to include in the design flood, but which may be considered when designing the superstructure and pier of the bridge. Scouring is the most important, once again most important factor. Scour is the erosive effect of water flow on the riverbed or bank. Scouring occurs when the velocity of the stream exceeds the limiting velocity of the particles in the stream bed could withstand. Bridge works may alter the existing scour pattern by restricting the free flow of the stream. About 50% of river bridge failures are due to scour. So, scouring is the most important phenomena which affects the life of bridge or structure. Scour protection. Therefore, we have to protect scour. Scour protection. River and scour protection is usually required where a bridge is built across a meandering stream, or when some restriction to the flow of the design flood occur at the bridge. Protection measures can take the form of riprap on slopes or riverbed, gabions, groins, pile walls, vegetation. This is the example of scour protection. Here, the stone which are kept sides of the pier, so we can protect scour or erosive work. This is another example of scour protection. Once again, example of scour protection based upon bridge type. The designer should consider all the preliminary data made available to him from the detailed investigations before arriving at a solution. The entire complete structure should be the most suitable to carry the desired traffic, adequately strong to support incident loads, economical and aesthetically pleasing. Factors influencing the choice: economics, available funds, approaches, level of permissible interference to the flow below, climate and environmental conditions, scenery from the bridge, topographical conditions, subsoil conditions, type of traffic, navigational clearance. Then span. When the span is high, superstructure cost is high, and substructure cost is low. When the span is high, superstructure cost is high and substructure cost is low. Experience has shown that at the most economical span length, superstructure cost is equal to substructure cost. Piers. piers are required to reduce the span of the deck, carries the vertical and horizontal loads of the deck. Generally, piers are underwater, should be designed to withstand hydraulic pressure and impact loads. Then abutments serves the following purpose: supports the dead load of the deck, superstructure, resists the vertical and horizontal live loads, retain the approach embankments, provide a smooth transitions from the road surface to the bridge deck. Then location of piers and abutment. Factors to be considered. The following factors to be considered for location of pier and abutment: foundation conditions, economical, span, navigational requirements, aesthetic requirements, river flow. It is preferred to align the piers and abutments parallel to the main direction of flow in the stream. This is important. It is preferred to align the piers and abutment parallel to the main direction of flow in the stream. Location of pier parallel to the main direction of flow. Traffic. Estimate the type and volume of traffic likely to use the bridge over the service life. Determine the current traffic and use a reasonable growth factor. Design loading. Most countries have some form of design loading standards for bridges. Available standards are British standards, ASTO and Eurocode. Subsoil exploration. The aim of the preliminary exploration is to get a general idea. The detailed investigation would call for careful sampling and thorough study of the engineering properties of soil and rock. The following methods can be used: test pits, hand auger boring, cable percussion boring, rotary drilling, and geophysical survey. Information from soil investigation. The following information which can be get by soil investigation: nature of soil deposits, depth and thickness of soil strata, groundwater table, depth of bedrock, and engineering properties of soils and rock. This is the example of borehole log. For preparation of this PPT, I refer this reference. Investigation of bridge is the important factor for the life of the bridge. So, this is important lecture. Before construction of any kind of bridge, you go through this lecture. This is most important lecture for civil engineers and also for geologists. Before construction any kind of bridge, you go through this lecture. This will helpful for you. So, if you have any doubts, please ask me in comment box. Thank you very much.